Hello guys, in this video we're gonna solve one of the questions that really very good one and then very insightful as well. So we learned in this chapter about the span of vectors. Okay, so this question is simple. Which is the following vectors doesn't span x and y? So we are giving two vectors. One vector is called x. Let's change the color here. This one here. And another vector called y. And these two vectors can make a span of like subspace. Okay. And here will be subspace of R4, of course, because we have the size here is 4 by 1. And we are given another two vectors. Let's call them, for example, A and B, or whatever you like. Okay. And we want to know if these two vectors is, can be located or part of the span of the subspace that x and y can create. Okay. We want to check if A belong to span of x and y, and also B, both. Okay. I'm gonna change the names a little bit. I'm gonna call them B1 and B2. I'm gonna explain y in a moment. So let's call them by B1, by B2. So this is B1 here and B2. Okay. Okay. So actually, this question is very nice, and very insightful. I'm gonna explain why now, because we learned about Gaussian elimination, which is done to a matrix basically to find the solution for some set of equations. Okay, and we learned that this set of equations should be like Ax equal to B. Okay, A is a matrix, and B is the vector of the variables that we want to solve for to find, and B is bunch of constants. Okay. So, and we learned it like, for example, if A is, for example, is like that, A, B, and C, D. Okay. And X, for example, is X1, X2. Very simple system. B1, B2. Okay, basically this is A, this is X equal to. This is just an example. We learned that to do this multiplication, we know that X1 AC plus X2 BD equal to B1. Oh, what does that mean? This is basically X1, which is just like a number belong to R, like 1.1.5 million, whatever. Okay, multiplied by the first column. The first column of A plus, well, let's call it V, because we learn we usually nominate vectors as V. So let's call it V1 plus X2, which is again like it should be a parameter belonging to R, the real numbers, like again 0.1, -1, 1 million, 10, whatever, multiplied by V2. So this is another vector here, which is second column of A, equal to what? What is this vector? This is V. Okay. And we learned in that chapter, that if a vector belongs to some subspace of another, like a combination of vectors, it should be, dependent on them. I mean, it should be equal to some constant or some number multiplied by the first vector plus, another constant multiplied by the second vector, third vector, and so on. Here, luckily, we have only two vectors. We have X and Y. So what we want to prove is that B1 equal to some constant, let's call it you know, H1 or A, I don't know, A and B, or H1 and H2 and H2, H1X plus H2Y, where H1 and H2 just some constants belong to R, real numbers. Okay? If we could represent B1 like that, then in that case, if that's true, that means B1 belongs to span X and Y. F, and this is the same for B2. If B2 can be expressed as, like, let's call it L1 and L1X plus L2, another constant Y. This is true. If this is true, where L1 and L2 again belong to R, and B2 belong to span X and Y. This question is a little bit different, you know, doesn't, which of the following vectors doesn't belong to the subspace of X and Y? So basically, we want to search for the one that doesn't belong. Actually, the actual question, you know, basically have 4 vectors. Let's call them B1, B2, B3, B4. I just put 2 here just to for simplicity, basically. Okay, so let's try both. But I'm gonna, before that, what I'm gonna do is that explain a little bit what is you know, the idea behind how to solve this, basically. Okay, so it looks like finding out if B1 and B2 belong to the subspace of X and Y, at the end of the day, it's like Gaussian elimination. Okay, and basically finding, you know, like the variables of like in some like equation systems. Okay, so and if there is a solution, okay, then B1 or B2 belong to the subspace of X and Y. Okay, so that's what we're gonna do. We're gonna express, we're gonna imagine there is a matrix called A. This A has 2 columns. The first column is the variable X, 1, 0, 0, 1. The second column is the variable Y, or the vector Y, which is 0, 1, 0, 1. Let's just, you know, check again. Yeah, yes. Okay. And then we're gonna find a variable. Let's call them, for example, x1 and x2. So we're gonna find out if x1 equal to b1, and x2 equal to b2. Okay. Can we find vector called x1 such that ax1 equal to b1? Can we find a vector called x2 such that ax2 equal to b2? If we could do that, then for x1 or x2, then b1 and b2 belong to the subsystem. If we couldn't find x1, basically it's not, the system is not solvable. Okay, then basically b1 doesn't belong to the subspace of A and B, because we cannot write b1 as constant multiplied by x1. I'm sorry, multiplied by x plus another constant multiplied by the vector 1. So let's start by b1. Okay, so I'm gonna write here the matrix A again. I think we can do copy and paste. Let's check. That's fine. So 1, 0, 0, 1. Oh yeah, we can copy and paste here. Okay. Then we're gonna first start by B1. So what we're gonna do is basically write a system of equation using B1. So what is B1 here? It's 2204. 2204. That's B1. Okay. Basically, we are trying to find if ax1 equal to 1. What is x1? x1 equal to x1, yeah, x1, y1, you know. A and B. Yeah, let's call them A and B. I know there are many variables here, might get confused. But anyway, so if we could find A and B, real numbers, then there is a solution. Then B1 belong to the subspace of X and Y. Okay, so that's basically very, easy, natural, like Gaussian elimination. So what we should do, we should start first by this one here, the diagonal, main diagonal, and make all the subsequent like elements equal to 0. So first row will stay the same. Second row will stay the same. Third row will stay the same. Now the fourth row is very easy. Just subtract, So basically this is R4, row 4. So row 4 new will be equal to row 4 old minus row 1. Okay, this is row 4 old, 114. So just, subtract 1 minus 1 is 0. 1 minus 0 is 1. 4 minus 2 is 2. Okay, we are finished by the first one on the main diagonal. Let's now concentrate on the second one on the main diagonal. Okay, and we should make all subsequent, elements in that column after that below this one equal to 0. This guy is okay, it's already 0. We just need this guy. So let's write this again. 0, 1, 2, 0, 0, 0. Then what we should do basically is subtract that row from that row, or basically subtract that row from that row. So R4 new equal to R4 old minus R2 this time. Okay, this is now R4 old. This is the second step now. So 0 minus 0 is 0, 1 minus 1 is 0, 2 minus 2 is 0. Okay, good. So that's what we end up with. Basically, this equation, these two equations just vanish, goes away. It looks like these two equations were dependent on, the other two equations, equation 1 and equation 2. And we end up with these two equations now. Basically, the second equation is 0x1 plus x2 equal to 2. And from that, x2 equal to 2. And the first equation is x1 plus 0x2 equal to 2. From that, x1 is equal to 2. So we could find x1 and x2. I should call them x1 and x2 here. I'm very sorry. Okay, or A and B. That's fine. A and B. So let's call this A. This is B. So B and A. This is A and B. That's it. Very sorry for this confusion, but so A equal to 2 and B equal to 2 as well. Okay, so that's solvable. So B1 can be like represented as a constant multiplied by x plus another constant multiplied by y. So it's equal to 2 vector x plus the vector y. So B1 here, which is the 2, 2, 0, 4, can be represented as 2 multiplied by the vector x, 1, 0, 0, 1, plus another constant, which is b or x2, whatever, multiplied by the y, 0, 1, 0, 1. Can we verify that? Yes, we can verify. So that will be 2, 0, 0, 2 plus 0, 2, 0, 2. Let's add them together. So we're going to get 2 plus 0, 2. 0 plus 2 is 2. 0 plus 0 is 0. 2 plus 2 is 4. That's basically that guy. Okay, so basically B1 span lies in the span, in the subspace made by X and Y. Okay, good. Can we verify that our solution is correct? Yes, because this system is very simple. Actually, let's write the system, of equation without making any Gaussian elimination. So let's write this here. I'm just giving you an idea that the system is even bit simpler than this to solve. So let's write the first equation. 1x1 or 1a, let's write it a, let's stick to a and b. A plus 0 equal to 2. Then 0 plus b equal to 2. Then 0a plus 0b, of course, equal to 0. Then a plus b equal to 4. From that equation, simply a equal to 2. No Gaussian elimination is needed. From that, b equal to 2. Again, no Gaussian elimination needed. But let's now check that equation, because that equation should be correct. So 2 plus 2, of course, equal to 4. So actually, we don't need Gaussian elimination. It's very simple to solve this system. So once you put that, you know, in one step, basically, you know that B1 spans the subspace made by X and Y. Now let's do the same for B2. Looks like B2 vector will be our rogue vector here, you know, that doesn't locate in the span of, or doesn't belong to that span. So let's copy and paste the system here. And we're gonna do the same, but B2 this time, not B1. So let's write that here. And B2, what is B2? B2 is basically minus 2, minus 2, 0, minus 2. Okay, let's minus 2. Yeah. Okay. Minus 2, minus 2, 0, minus 2. Okay. And this is actually B2, not B1 anymore. Okay. I'm gonna do again Gaussian elimination. So after doing Gaussian elimination, you're gonna find that it's very easy, you know, to know or to solve it. You know, so this is basically a x2 this time equal to basically b2. X2 again equal to a and b. You know, some people usually use x1 and x2, but we're gonna confuse with the name of the vector, so let's call it a and b. Okay, let's see if we can do Gaussian elimination here. It's very simple again. So 1, 0, minus 2, 0, 1, minus 2, 0, 0, 0, no problem. Then 1 minus 1, 0, 1 minus 0 is 1, of course. Minus 2, minus 2, it will be minus 2 plus 2, which is equal to 0. Okay? Continue. 1, 0, then minus 2, 0, 1, minus 2, 0, 0, 0. Now we're going to concentrate on that one here. I should make that one equal to 0. Just subtract. 0 minus 0 is 0. 0 minus, I'm sorry, 1 minus 1 is 0. 0 minus minus 2 is 2. And just pause here and look at the system that you have. From that equation here, remember this is just an equation, okay? You are saying that 0a plus 0b equal to 2. You are saying that 0 equal to plus 0 equal to 2. That's of course wrong. That's not valid at all. Then there is no solution for that system. There is no solution for that system. What that means? That means there is no vector called x2 a and b such that a x2 equal to b2. No x2 equal to a and b such that a x equal to b2. Then b2 doesn't belong to the span made by x and y. The subspace made and x and y. Can we do that without using Gaussian elimination? Yes, we can do. You know, let's can we discover, I mean, that there is no solution without making Gaussian elimination? Yes, we can do. Let's do that. So let's write the equation. From writing the equation, we're going to discover that very easily. So the first equation is a 1a plus 0 equal to minus 2. Good. Second equation, 0 plus b equal to minus 2. That's also good. Then 0 plus 0 equal to 0. That's also good. then A plus B equal to minus 2. Okay, from the first equation, we learn that A equal to minus 2. Very easy. From the second equation, we learn that B equal to minus 2. Very easy. So far, so good. Third equation doesn't give us any information, but the fourth equation is saying that minus 2 plus minus 2 equal to minus 2. Is that correct? No, because the left-hand side is minus 4, and the minus 4, of course, doesn't equal to minus 2. So again, the system is not solvable. There is no A and B such that AX2 equal to B2. Or we cannot say that A, the vector X plus B, the vector Y equal to B2. We cannot say so. That's not valid. We cannot represent B2, vector B2, as a linear, combination in vector X and the vector Y. So the solution here is that basically B1 belong. That's good. B2 doesn't belong. Okay, guys, that's basically a very simple example, but very powerful one. It will teach you Gaussian elimination again, although you should be master it by now. And it should teach you again about subspaces and their properties. Okay, and of course it will teach you how a vector span and what's the consequences of a vector spanning some subspace. Okay, guys, thank you very much for watching, and see you in another video. Bye.